Hello everyone, and welcome to our presentations for CSS332 Microcontroller and Applications. Today we are excited to share with you our project, a wireless doorlock system with sensors. This system combined convenience, security, and affordability using simple components and microcontroller logics. I'm Choltawat and my partner Kantheedeth. Let's dive in. Okay, learning objective. Our project has three main learning objectives. First, to design and implement the secure door lock system by using Arduino and servo motor and various sensors. Second, to allow wireless controlling using 433 MHz remote and provide real-time feedback to the user via an LCD display. And third, to improve safety by detecting improper locking attempts and giving audio warning through a buzzer. Our concept: we create a smart anti-thief door locks using an Arduino Uno as the brain of the system. The doors control wirelessly using 433 MHz remote. A servo motor handle the physical door lock mechanism to ensure safety and read switch check if the door is successfully closed before locking. An LCD screen shows the current lock status, and if someone tries to lock and open the door, the buzzer gives us a warning. Our goal was to build something useful, simple, and affordable in real life use. Alright, hardware components we have used. Here are the components we have used to build our system: an Arduino Uno microcontrollers, a 433 MHz RF receiver and remote control, a servo motor to lock and unlock the door, an I2C 20 by 4 LCD screen for the feedback, a read switch to detect the door positions, an active buzzer to issue alerts, and of course, a board with jumper wire to connect everything. Okay. Okay, let's writing diagrams. This is a simplified writing diagram of our system created by fixing the servo motor. As you can see, it is connected to the Arduino for the movement control, and the 433 MHz receiver receives the signal from the remote to control locked or unlocked. The read switch tells the system if the door is actually closed. The LCD connected through I2C, making it easy to use fewer pins. That's great news. And the buzzer alerts the user if there's a locking error, which is the door is not completely closed. And these components work together to make our smart door lock system reliable. All right, let me give you an example for the doors. For example, if the door is not completely closed, if we press the buttons, the alarm will show the sound. That's not probably closed. Okay, and the magnetic sensor to detect if the door is closed probably, and we press, the door is locked here, and if we press again, it should be unlocked here, and yep, if we press lock again, unlocked. If we remove this, which is the door is open, it can't be locked, and the sound appear. That's it.
Okay, let's get into the code part. The first 3 lines is the library inclusion that we include the library of each component in the board. We have servo motor, the Y, which is create the communication between our board and LCD screen, and liquid crystal I2C. This is library for our LCD screen. And now we create the object named log servo, which is the servo type. And we create the constant, which is the number of each pin. We will let the servo pin to 9 and read pin to A3, buzzer pin to pin 10, and the button pin to pin 4. And we create the boolean is locked to see if the door is locked or not. And the last button state is to help detect when the button is newly pressed or not. And this is the setup of our LCD screen. The 0x27 is the address of our LCD, and 20 and 4 is the size of our LCD screen. Now we will initiate each pin to input or output. First, we use read pin as input. The read pin is a sensor that will detect if the door is closed, completely closed or not, and the buzzer pin to output and the button pin to input. The reason that we use input pull up because we need the reliable readings, not the checking signal, and we write the buzzer pin to high because it is the active low buzzer pin. So if it has signal low, it will work. If it has high, it will not work. So we don't want it to work at the first place, so we initiate it as high. And the lock servo attached means we connect the servo to pin 9 as we initiate the servo pin to 9. First, and to the LCD. The LCD init to initiate our LCD screen. And we have them to delay because we have some power issue because we have a lot of components in the board. So we have to make the timing right and turn on the backlight, and we set cursor to 0, 0, and then we will have the welcome text as smart door lock and for 1.5 seconds, and then we clear and we will show the status of the door. Now to the loop part. We have two more boolean, the digital read button pin to read the signal from our pin, our button, and boolean door code to have show the status that the door is closed or not. Now to the condition. This line, if button state equal to low and last button state equal to high, it means there's a transition between signal from high to low. So, and we will give them a delay, and we will check the condition. If the door isn't locked, it means unlocked. We will check if the door is completely closed or not by using read switch. If the door is completely closed, it will lock the door. If it's not, it will appear this text can't lock open on the output on the screen, and the buzzer pin will working for 1 second. This is the else condition. If the door is already locked, it will lock again. The last button state equal to button state to update the status of the button that newly pressed. Okay, and the next part I will leave it to my friend.
All right, so let me continue to the Boolean part. we create a boolean named is door closed to check whether it's closed or not. And as you can see here, we check the reading if it changed. These functions read the read switch, which detect whether the door is closed, but to avoid false trigger from electrical noise, which is a pause we currently have. Okay, this is for the fixing these issues. And we use debouncing techniques to fix this. All right, we check the reading has changed here to check the if it's changing, and if it's changing, we reset the timer. Here's a reset if it's not equal, so make it equal. All right, only for only the state reading for 50 milliseconds here to check if it is if the combine here minutes more than the bounce delay here, make it equal. And for the last reading, equal to current reading, and return to the last stable state to make it stable, of course. And for the void here, we create lock and unlock functions. Let me assume the first one is the lock door. As you can see, this function turns the servo motor to 0 degrees. Here, turn it to 0 degrees means change nothing, do nothing. And we set the delay to 500. All right, and is locked equal true. Then we update the door lock to true. Then we update again to refresh the LCD display. In contrast, we have this unlock door. It's slightly the same as the previous codes, but right now we have the same delay, of course, and we set the door lock is to false to make it difference from the others, and we set it to 90 degrees. It's meaning that at the first the door is locked, it's 0 degrees, and when it unlocks, it's gonna turn 90 degrees. All right, and the last code we update the display to make it keep running as like a loop, and we clear first. At first we clear. This function keep the user informed. It clear the LCD and display the current lock status. It check the door is locked and print either the door is locked here or the door is unlocked. All right, this make for the user friendly and easy to understand the system state at glance. All right, let me summarize for you. For a quick summarize, we have this part is a read switch rapidly detects the door state using the bounce logics, of course, and we have the servo motors move lock to unlock the door and lock the door from 0 to 90 degrees, and we have LCD display keep showing clearly show the what is happening. All right, together these components create a smart and responsive, easy to use, of course. All right, and that's it for our presentations for explaining this code. Thank you for your listening. To complete this project, we use several resources. An official Arduino documentations help us understand pinouts and servo control. The liquid crystal I2C library made displaying messages on display LCD easy. The built-in servo battery and library control to lock the mechanism. Freezing help us to visualize the circuit. These two made to learn our learning experience efficient and effective. All right, thank you for watching our presentations. We hope you enjoy learning about wireless doorlock system project we have created. If you have any further questions, feel free to reach out in the comments below.